Good morning, everybody. Good morning. I'm going to get started because we're 5 minutes late already. So, good morning. My name is Leers. You can find me on Twitter and on my website. I'm a senior software engineer in the office of the CTO at Acquia. I used to work on things like Spark Drupal, so improving authoring experience, but for the past year or so, I've essentially been doing nothing else besides working on Drupal 8 performance, fixing beta blockers and fixing critical issues. One of the things I've been working on lately is the render pipeline for Drupal 8. And it's kind of ready just in time for this presentation, so that's great. What I'll be talking about today, the render pipeline in Drupal 8, is not actually available in Drupal 8 right now. Most of it is. 90+%, probably 95, probably even more than 95, is going to be exactly like presented here. But we're still in the final review process for one big patch, and everybody's on board with this approach. It was long discussed over many hours in DrupalCamp Amsterdam, amongst others. So what you'll be seeing here today should hopefully be the final render pipeline for Drupal 8, and if not, then it will be very close. So gonna get started. Our guide today is going to be, unfortunately not a llama, but the diagram that you might have seen on Twitter in the last few weeks. And yes, that's enormous, and yes, that's not legible from where you are sitting, but that's the point. Because what we'll be doing, is using it as a map of Drupal 8. And essentially the explanations on the right-hand side are kind of driving instructions, if you will. And in this talk, we're going to look at each area on the map, on the diagram. And by the end of this talk, if that's my plan, hopefully I'll succeed in that, all of you should feel like you understand Drupal 8 to some extent, as in how requests are handled, how responses are generated, and that sort of thing, which is very crucial for any web application or CMS. So I think if you have this, then you have a starting point into fully understanding the details of the render pipeline, as in looking through the code and nodding, yep, that makes sense, that sort of thing. And once you have that starting point, then it's much easier to dive into other parts of Drupal 8. So I hope it's a good starting point to get to know Drupal 8 better. And if you were arriving in the last few minutes, then you might not have seen the slide that I had up just before. So please download the PDF with the diagram at wimleers.com/drupal-8-render-pipeline.pdf. That makes it easier to follow along and to make sense of that big PDF. So assuming that you have that, let's get started. So the map we saw earlier, the diagram, was a bit bigger than this. So if we remove the driving instructions, if you will, the explanations on the right-hand side, it becomes a little bit simpler already. But what's always important in a map is to have orientation points. And in the top left-hand corner, there is the incoming HTTP request that we are going to answer. And the bottom left corner, there is going to be the response that we send, hence the end of the request. So from top to bottom, we are working towards getting a response ready to answer the requests. And from the left-hand side to the right-hand side, we're getting deeper and deeper into Drupal itself. So that's kind of the large-scale layout of the diagram. That should help already. Now, if we look at the different visual islands, if you will, the visually distinctive areas on the map, and these are kind of the steps, and these are also the steps that I'll be going through during the presentation, and hopefully it'll all make sense to you by the end of it. So let's get started. On the left-hand side, we begin with index.php. And I think most of you already know this because this already existed in all previous versions of Drupal. So there's nothing new there, except that we now have probably a better way to define it. It's what SYMFONY calls a front controller. And SYMFONY defines it as a well-known design pattern that is a section of code that all requests that are incoming are going through, and then the application responds to it. So index.php, which might have seemed a little bit mysterious and bizarre in the past, it's there for legacy reasons. It's a front controller, nothing more, nothing less. And in SYMFONY, this is usually called an app.php file. also a front controller, but they typically call it app.php instead of index.php. But it's just the same. It doesn't matter. You don't ever see it on the outside. The end user never sees it. It's merely an implementation detail. But what does index.php do? Because that's what we care about. So its responsibilities are, given the PHP request metadata, so the $_request super global, index.php turns that into a more well-defined object called the SYMFONY request object. So we just create that, where we have richer ways of interacting with the request data. And then the important part, we create an HTTP kernel. That is really the most crucial thing in Symfony. It's, I think, the first thing we adopted from Symfony. Many projects are using it and adopting it. And the HTTP kernel is really, really important. We'll see more about that in a second. But to contextualize things a bit more, when we're creating the HTTP kernel, we also initialize the container. You might have heard about the dependency injection container before. This is where that gets initialized. We won't be covering more of that, but you have a sense of where that gets initialized now, which is important. And settings.php, which you all know probably, that's also taken into account at this phase already. So this is still very early in the request, right? Because it's still index.php, the very first thing that is doing any, that is handling any requests. So once we have the HTTP kernel initialized, and we already have that request object, we just ask the HTTP kernel to handle the request and give a response back. And as you can probably sense, that is really the key part of index.php, calling the HTTP kernel, giving it a request, and expecting a response in return. So that's what we'll be diving into next. But index.php does slightly more still. Once it has that response, it is going to prepare the response, which doesn't really matter that much, but it prepares the response and then it sends it. And the sending actually sends the response to the end user over the internet. And then finally, after the response has already been sent, we terminate the HTTP kernel. Now, if there's any Symfony developers amongst you, how many among you, can you raise your hands, have worked with Symfony itself already? Okay, so like a dozen or so. So this should hopefully seem very familiar to you, because this is exactly how any Symfony project, any Symfony front controller works. So it should be familiar. Now, if we look at the next step, as I said, HTTP kernel was the next important thing. So if we look at how it's handling the requests, well, then we'll see that it's actually an arbitrator. It decides what happens with that incoming request. And HTTP kernel is really the heart of Symfony, and because Drupal has adopted Symfony, at least to this degree, it is also the heart of Drupal now. If you want to learn more about it, the slides will be online at the end of this talk. And at that URL, there is a Symfony docs, which are quite nice and explain it quite nicely in more detail. But HTTP kernel, its responsibilities. So HTTP kernel handle, that is. Given a request, it first triggers a request event. So it has a request, and the very first thing it does, it triggers a request event that subscribers to that request event can reply to and do actions in reply to. So one of the things that's happening is negotiation. So for example, negotiation is about choosing which format to render the response in, so HTML, JSON, XML, whatever else. But also routing. So given the URL that we made a request to, routing determines which code is going to be called to generate content, generate a response to send back to the end user. So request is the very first event that happens, and quite important stuff is already happening in there. Next step, because routing already happened, we are going to load the code that contains, usually a class that contains the controller, which is a method on a class that is going to be called. So routing determined which controller to call, just like page callbacks in Drupal 7. In Drupal 8, usually that is going to be a class. If you want to, you could still make it a procedural function, though there's no good reason to do that. But in any case, in step 1, the request event, during that we did routing, we know which controller to call. So now we load the controller, we trigger the controller event just after that, and this allows you to, at the very last second, still override which controller gets used. So that's already an interesting ability to override things. The next step is, given that we know the controller, which controller to call, which method to call, we can look at the arguments that it expects, and then Symfony does introspection, so it looks at whatever the arguments are that the controller expects, then make sure to retrieve them from the request, and if necessary, do parameter conversion. So that's, for example, if you are making a request for node/1 or user/5, that is going to make sure that the entity, the node5 and user3 objects, are actually going to be loaded and passed into the controller itself. Then we actually call the controller. So everything up till now was about determining which thing to call, determining how to call it, the arguments, and then just calling it. That's really the key part in any web application, I think, in any CMF. So calling the controller is really the key. So that's what we'll be looking at next in more detail. And if the result of that controller is a response object, so remember that in index.php we called HTTP kernel with a handle method and give it a request. We expected a response to be returned. Well, this is checking if what we are getting back is already a response object. And if so, we are done. So if the controller returns a response object, all of the work stops, nothing else is executed inside Drupal. That's it. Symfony just sends it and that's it. However, if it's not a response object, then another event is triggered called the view event. And the idea is that if you're dealing with something other than a response object, that we still need to turn it into a response object, because that's the entire architecture of Symfony. You give it a request, you get back a response. So whatever you do, you have to end up with a response. Otherwise, you don't have anything to send to the end user. So the view event allows event subscribers to look at whatever object was returned instead of a response object, and then decide to render it in some way into a response object. And this is also really key, the view event. We'll look at that more a bit later. And finally, once the response is ready to be sent, at the very last second, again, just like for the controller, it is still possible to alter the response. For example, something crazy, you could replace every instance of the with yar on Pirate Day. I'm not sure why you would want to do that, but this kind of global manipulation of the response is still possible. So this is really all that the HTTP kernel does. And I think that it kind of makes sense, because these are all very high-level things about determining which thing to call, calling it, getting back something to send to the end user, if not, making sure that we get something to send back to the end user. And this is the diagram that Symfony provides for it. So on the left-hand side, we have the request. On the right-hand side, we have the response. And the blue rectangles are request, controller, view, and response. All of those are the events that we triggered. And as you can see, first we trigger the request event. Then we figure out which controller to load. Then we trigger a controller event to still allow it to be modified. We figure out which arguments to pass into the controller. We call the controller. And if the controller returned a response, we don't go to the view event below. We go immediately to the right, trigger a response event, and send a response. But if the controller did return something else, like a render array or whatever other kind of object, other than a response object, the view event is triggered, and then that is responsible for generating a response object. So the possibilities with this are also quite interesting, precisely because you have events at various stages, very distinct stages, and that makes sure that anything is possible, really. So for example, you might want to have an event subscriber for the request event that in a very early, very efficient manner determines, oh, but my site is offline in this country because we're doing maintenance in that specific region. I don't know, some crazy edge case. And you don't want your site to be slowed down because you're doing maintenance-y stuff. Well, then maybe the kernel request event can already return a response. There is no problem with doing that. The response event, you can do crazy alterations, as I mentioned. But as you can sense, these are kind of like the hooks we had in Drupal 7 and before, and we still have in 8. But these ones are a bit more fine-grained and more interesting than the ones we had available. So if we look at then the next thing, which was going to the controller, which was the next big thing, we have to do that via an event. Or rather, to get to this point, we have used quite a lot of events. And that's the next layer. So the first step was index.php, then the HTTP kernel, which is the heart of Symfony and Drupal, and then the event handling. That is really the glue between both Symfony and Drupal. If we didn't have any event subscribers in Drupal, then that would mean that basically nothing in Drupal would be executed. So the events are really the thing that makes the bridge between Symfony and Drupal on the other hand. Many of the events are triggered by HTTP kernel, but Drupal can, of course, also use events and actually does. So far, it was all the dry, high-level stuff. Index.php, Symfony, HTTP kernel, and Symfony events. And that's really all the high-level stuff, the things that are arbitrating, directing the high-level things. But now we get into the territory that probably most of you are most interested in, which is a controller, the logic that you write to return some response, some content. Well, in this case, we have so it's kind of like a page callback in Drupal 7, of course, and determines the content of the response. And it can choose to return either of three kinds of return values. The first is a response object. As I said before, that immediately goes down to, it skips all the Drupal stuff and immediately is sent. If you have the diagram open and you look at the controller part, then the response object should be marked in red with a dashed line in red from the controller right to the end of the application, and that demonstrates that all of the stuff on the right-hand side in the diagram is just not executed. It's immediately going to the end. So the second thing is that is usually returned is a render array, and a render array we are all very much familiar with. And we'll look at that in more detail in a second, but that's the other kind of interesting return value, the other type of the three possible return values. And it has the green arrow, and it's the longest flow because Drupal does the most interesting things to render arrays. So if you look at the controller in the diagram, you'll see a green arrow through the diagram pointing towards the end. And finally, an object, if you return some other kind of object, it has to have a view subscriber, as I mentioned before, to turn whatever object you are returning into a response object. Render array is the most important one, so we'll look at that in more detail next. And the possibilities here are also quite interesting again. So if you return a response object, you can fully control what is sent. Because in Drupal 7, you had no way of doing that except for printing a bunch of things and then calling exit, which was definitely not very elegant and can cause quite a lot of problems. So now in Drupal 8, you have a very clean, very semantical way of doing that. The other thing you can return is a render array, and in that case, we let Drupal take care of sending, and we'll look at that in more detail next. And then an object. An object should probably represent some kind of semantic data, and you can have multiple view subscribers operate on them. So in the example at the bottom, a tabular data object. I'm not sure how realistic this is, but it's feasible that you would have such a use case. So imagine that you are working with a lot of data sets, and many of them are tabular data. If your controller then returns a tabular data object and not doing any rendering, just returning that object, then you can have a view subscriber to render it, for example, as a CSV file. You can have another one that renders it into an Excel file. You can have another one that renders it into an HTML table, another one that renders it as a PDF file, and whatever else. So the interesting thing is that your controller can just determine which thing should be rendered, but not in which way. The which way part can then happen in a view subscriber to support a huge variety of different formats. Now, so now that we know what kinds of things a controller can return, which is response object, render array, or some other kind of objects. Response, we don't do any further work. An object, we have to write a custom view subscriber because Drupal cannot magically know how to interact with that kind of object that you are returning. So we cannot explain that in this diagram except for showing that it goes through the view subscriber, through the view event. As you can see, if you follow the blue dashed line, dashed arrow in the diagram. But the interesting part is a render array, because since forever we have been using render arrays and doing interesting things, interesting transformations with them, on them. So render arrays being returned were typically seen, and like in the 99% case, are typically seen as the main content. And by that I mean that usually whatever your controller returns is rendered centrally on the HTML page, but then it's rendered with blocks around it. So it's kind of decorated main content. The main content is rendered as is, comes from your controller, and then the blocks are rendered around it. The main content view subscriber is the view subscriber for handling render arrays and turning them into responses. So it's is handled just like any other object that you might want to return, but we only, out of the box, support and can support the handling of render arrays towards responses. And that's what the main content view subscriber is responsible for. Or rather, it is really responsible to choose how to render it into which kind of response. So it's an arbitrator again, and it, as the slide says, it only renders render arrays, nothing else. And what it does really is it selects and calls a main content renderer depending on the negotiated format. So if you have a regular browser that is requesting an HTML page, the HTML main content renderer would be used. If you have a request from the Drupal Ajax system, then the format that was negotiated would be Ajax, and we would use the Ajax main content renderer, and so on. So the possibilities here are quite interesting again, I think, because you can have some view subscriber with, for example, that tabular data object. You can have a view subscriber for that tabular data object, turn the tabular data object into a type table render array, so a standardized Drupal table, and then have the main content view subscriber detect that it's a render array that is being passed around, and render that just like any other render array. So you can have multiple stages interacting with each other, helping each other, so you can build very complex flows if you want. Of course, you should keep complexity in mind, but the possibilities here are very, very wide. So let's take a look at those main content renderers. And these are the actual render array to response logic things. And we have one main content renderer service per format, so an HTML one, an Ajax one, modal one, dialog one. So responsibility, turning a render array into a response. And Drupal 8 already supports these four. The first one, HTML, of course, is the language of the web, so we have to support that. But Drupal already has 3 additional formats that are supported that are Drupal specific for its Ajax system and for rendering any main content. So any controller that returns a render array can automatically be rendered in a dialog, can automatically be rendered in modal. And the interesting thing is you can add your own main content renderer services. So for example, you could add one that renders into PDF automatically. You could add one that renders into PNG automatically, or maybe more interesting things. Lots of possibilities again. So having covered everything in the diagram, really, let's take a look at the big picture, at the diagram in specific. So this was the big diagram, but by now you probably have a better sense that indeed from the left to the right we are going deeper and deeper into Drupal. And from the top to the bottom we are going towards the end of the request. We're building a response as we go towards the bottom. And if we flip things around a little bit, so flip it to the right, 90 degrees, then we can really see the different layers quite clearly. First there's index.php, then the Symfony HTTP kernel. Events are triggered by the Symfony HTTP kernel. The controller is called by the HTTP kernel, but then events are used to call the main content view subscriber in case of a render array being returned. And then the main content view subscriber decides which main content renderer to call. I hope it all makes sense to you, and that the diagram will therefore be more useful to you from now on. I hope you have ideas already on how you can use this and how you can do interesting things with this. But I think one of the most important parts, as usual in the web, is the HTML main content renderer. So let's take a bit more deeper look at that one. So what it is, it's the most commonly used one since we usually render HTML. But the very interesting thing in Drupal 8 is that it supports page display variants. Page display variants were introduced a few months ago, but they were kind of crippled in the sense that it was kind of hard-coded. You could only have the page display variant for blocks. But the interesting thing is that this is about alternative methods of rendering main content. The block module in Drupal 8 is optional, so you can disable the block module and not use the block page variant. But you can also install additional modules to have alternative ways of filling page HTML twig, because that is what the main content is all about. It's about, in the case of HTML, it's about filling that page HTML twig templates in some way. Page HTML twig contains various regions, and usually we put blocks in those regions, but you could put other things in there if you would want to. And That means that block module is no longer a special citizen. It's implemented in the same way as, for example, panels and page manager will be able to be implemented in Drupal 8 in a much simpler, more maintainable way. And by default, of course, we still have the block page variant, so main content with blocks around it. But if you look at how it actually works, if we are getting a render array that is already type page corresponds directly to page HTML twig, so page tpl.php in Drupal 7. So that is kind of the body of the HTML. And if we already are getting a body for the HTML, then we really have no work left to be done because we already have defined what the entire body should look like. So in that case, we skip towards step 4. But if we don't have a type page render array, then we trigger a new event called the select page display variant event, during which a page display variant is selected. And we can then, given that selected page display variant, call it, give it the main content, and then it will render whatever that page display variant is designed to be doing. So for example, the block page display variant will render the main content centrally and then render the various blocks around it. Page manager might override everything inside the main content and do something completely different. Whatever you want to do is possible there. And then once we reach either the end of 1 or the one at the end of step 3, we are guaranteed to have a type page render array, because that is the goal. We always want to have a body to fill the HTML page with, right? That's otherwise an empty body doesn't make any sense. So by the end of having that type page render array, we wrap it in a type HTML render array, which means that the HTML twig file, I don't remember if that existed in Drupal 7, maybe it didn't, I'm not sure anymore. But basically, we have HTML twig as a template, so that would be the equivalent of html.html.tpl.php, rather html.tpl.php in Drupal 7. And we basically say the body that we have, the type page render array, we put that inside the body of the HTML template, HTML twig, and that's it. That's our entire assembled page, so we can then Drupal render everything. So now, during the entire cycle of building an HTML page, it is all consistent, the same system, no hacks, the ability to easily insert something like panels. But it also means that you can implement panels page manager without hacks, finally, so it will work more reliably. And something maybe that none of us have even thought yet, maybe one of you will develop something that is even more powerful, more interesting, more enabling for site builders than panels already was. And another interesting thing that we might be able to do is, instead of using the default block page variant, which just renders the straight HTML and sends that, is a big pipe variant of block page variant. So I don't know if many of you know BigPipe, but BigPipe is basically an alternative rendering strategy that was developed at Facebook maybe 4 years ago or 5, I'm not sure anymore. But what they did was, they also have the concept of blocks, kind of, and they didn't actually render the blocks, because rendering the blocks takes time. And maybe there is expensive content in those blocks. For example, a lot of views that are containing lots of dynamic, quick, fast-changing content. And in that case, you really want to have the main content of the page sent as fast as possible. So instead of rendering the blocks, they just rendered placeholders for those blocks, kind of visual, empty thingies. But because the user's attention is drawn towards the main content anyway, the user gets to see the main content much faster. The overall site experience feels much faster. And then via JavaScript, we can retrieve the actual contents of the various blocks after the main page has been loaded, after the main content was seen, and then only show the blocks. And that creates a much more fluid, much faster experience. So that is one very interesting thing that you could do with page variants. So it's not only about filling page HTML twig with actual HTML, actual final HTML in different ways. You can also do interesting optimizations like this. And you could even make it so that if your site, for example, has one super expensive block because it is incredibly dynamic, then you could override, you could subclass block page variants and let everything work in the exact same way, and just for that one block, implement something special. That becomes easy now, and in Drupal 7 that was a pain. So that is pretty much everything I wanted to cover about the diagram. I hope that it's much more clear now how Drupal 8 page rendering works, and hopefully it's a good stepping stone for you to dive into Drupal 8 with more success and confidence. But a little bit more about render arrays, because I promised in my session proposal to talk about that, but obviously this already was covered. This was quite a meaty piece of a talk, so the other areas I wanted to cover, I will cover in only one slide, but I will refer to other talks I've given with much more information about these different other subject areas. So assets, cache tags, bubbling, and render caching are the ones I'm going to cover still, each in one slide. So in Drupal 7, this was kind of the picture. Loading JavaScript on all the pages, that's what it was doing. You should try to get a simple page where you don't load any JavaScript. Do not load jQuery.js and Drupal.js. It is impossible. It is literally impossible. Drupal 7 was not designed to do that. It was designed to always load those. But if you're on a mobile device and you have to load jQuery, that takes on slower devices easily several hundred milliseconds just to parse, not even to download, just to parse. So that can be quite expensive and very much unnecessary if you aren't doing any JavaScripty things. So that was a problem in Drupal 7, and in Drupal 8 that's no longer the case, because now we are enforcing you to use asset dependencies. So in Drupal 7 already you had asset libraries via hook library info, and you could declare dependencies there. So this asset library depends on this other one, so if this one is loaded, then the other one that I depend on should also be loaded, and hence automatically make sure that the necessary things are being loaded. Well, in Drupal 8 that is now a requirement instead of an optional thing, and therefore we were able to get rid of always loading jQuery.js, Drupal.js, and others. So if you want to learn more about that, see the talk over there. I will put the slides online later so you can have clickable URLs and don't have to write down anything. Cache tags. We can summarize cache tags with one simple question, which explains why they exist. How to clear all cache items in any of your cache tables or other cache backends that contain something of node 42. Well, the answer is that you can't, and cache tags are the answer to that. The reason is that if you want to find all the things that contain something of node 42, that you cannot do that by looking at the cache keys, at the cache ID, because the cache key can be of any form or shape. So you would have to embed every single thing that was contained by the cache item. So for example, if it contains nodes 1, 3, and 5, then it would have to have nodes 1, 3, and 5 in some way embedded in the cache ID. But cache IDs are not even guaranteed to not be modified by cache backend. So how does that work? And how can you do even combinations of things? So if you have changed node 3 and user 5, how do you find only those cache items that contain both those entities? The answer is you can't, and that's where cache tags come in. So cache tags are an additional piece of metadata that are stored with every cache item, and they list the various things that they are actually using, the things that they are depending upon. So if you render something that contains, or if you render, for example, node 3, and node 3 contains user 2 and taxonomy terms 1 and 2, well, then that would mean that we would have to tag it with node 1, user 3, taxonomy term 1, taxonomy term 2. And then all of those tags are listed in the cache item. And that's how we are able to determine exactly which things should be invalidated. Because in Drupal 7 you had only two options: either invalidate not enough things, because you cannot possibly figure out which cache items contain something from a certain node, or invalidate everything, clear the entire cache, but then you're throwing away so many things that aren't affected by the one thing that has changed now. So cache tags are the solution to that, and I have a very short code example below. So in Drupal 8, loading a node looks something like this. So node : load, node ID, and you get a node entity back. But in Drupal 8, every single entity, and everything is an entity now, so users, nodes, taxonomy terms, files, everything is an entity. And every single entity also has a get cache tags method. that simply returns, given an object, given an entity object, get whatever the cache tags are that are associated with that object. That allows us to not have to do error-prone manual construction of entity type ID, append a colon, append a number. No, it just allows us to call a method and be done with it and not make any mistakes. So associating cache tags with a render array looks like that. Pound cache, as existed already before, but there is a new property below that called tags, where you have an array of cache tags. Cache tags are always strings, and they're always of the form some namespace, in this case node, because it's node colon 42 that the cache tag is, so namespace colon some identifier. And that's how cache tags work. It's really just a set of strings in a certain formatted way that are stored with the cache items, and that allow us to find just those things that are affected by changes. The next thing, bubbling. So in Drupal 7, we were using globals. We were using globals all over the place, and especially for assets. So for assets, we called the Drupal add.js function that stored something in a global static somewhere. But then if you called Drupal add.js, then that actually meant that a render cache item didn't know about the asset that you put in some global somewhere, because it is impossible to know that Drupal add.js was called for this piece of a render array. So you had to use pound attached already in theory, but in practice many don't. In Drupal 8 it's now enforced, so you have to use pound attached to add stuff. You can also do pound attached in the theme preprocessing layer, for those of you worried about that. But what matters most is that we now have correct bubbling of all the metadata that needs to be bubbled with a render array. So a render array can have, for example, associated cache tags. It can have associated attached assets. And all of that information needs to bubble up to the top level of the page, because how else is HTML going to know that it needs to list all these CSS files and all these JS files? It used to work just kind of through a hacky global static, through multiple global statics actually. And it worked as long as you didn't do any render caching. With bubbling, Drupal render calls recursively into the different layers of a render array. So it goes into the children, then the grandchildren, and so on. And it bubbles that information up as it goes down and goes back up again. One example of doing that is the cache tags associated with it. So this is a schematical representation of a render array representing an entire page. So imagine that we have a page with two regions. In the first region, there is a block that has a single cache tag. So that cache tag then gets bubbled up to the region and then gets bubbled up to the HTML tag eventually. Similarly, in the second region, we have two blocks, one with a view in it. That view cache tag gets bubbled up to the block. From that block, it gets bubbled up to the region, to the HTML. And the same for the fields in the node in the second block. So the fields, the cache tags, the multiple cache tags of all those fields are bubbled up into the node, from the node into the block, and so on. And by doing that bubbling, we have a complete overview which things are on the page, both assets and cache tags. And it also allows us to do a very, very cool thing if you have a lot of anonymous traffic and are using Varnish, which probably are quite a few of you. We now have in Drupal 8 something called the X Drupal cache tags header. X because it's a custom header. Drupal cache tags because it lists all the cache tags on the current page. And that means that we can now very efficiently have Varnish cache purging, for example. So if you have 1 million pages on Varnish and you change one node, how are you going to invalidate just the pages affected by that node change in Drupal 7 today? You're probably going to figure out which paths probably have that node, but probably you're going to miss a few because maybe it's in a block somewhere and you didn't realize that that block appears on these other pages as well. So it's very difficult today to correct invalidation of Varnish, or in general any reverse proxy or a CDN. With the X Drupal cache tags header, that is actually going to become trivial, absolutely trivial. So it will be possible to have huge amounts of pages for anonymous users cached in Varnish, not hitting Drupal at all, and then invalidating, whenever there is a change, only those pages that are actually affected and not making some best guess. So that is going to be very powerful. And really all of the above, the asset dependencies, the cache tags, and the bubbling are all necessary for render caching to work, because render caching already exists in 7. It was added in Drupal 7, but the important thing is that nobody was using it, or almost nobody. Can I Can you raise your hand if you ever used render caching in Drupal 7? Literally 0, it seems. Maybe one person over there. Wow. Yeah, so few people knew how to do it because it was so tricky to do, precisely because of these problems. Asset dependencies. As soon as you called Drupal add.js or CSS, you were screwed. If you didn't have cache tags, then there was no way to invalidate the render cache items correctly. You couldn't possibly know which things to invalidate precisely. So only now in Drupal 8, with those additional improvements to dealing with render arrays, it is possible to efficiently do render caching. And render caching is really just caching parts of a page, caching fragments that are expensive to build, caching as big as possible fragments. So in Drupal 8, we render cache automatically blocks and every single entity. Every single entity is varied by whatever is necessary. So for example, nodes are automatically varied per authenticated, per role. So per combination of roles, you get a different cache item, which means that there isn't any information being leaked and so on. So render caching is great for accelerating Drupal sites. And as a closing note, let's visualize cache tag bubbling and render caching in Drupal 8. So I have here a Drupal 8 page that is now static, but I hacked it to add some additional information on top. And you see yellow outlines over here, here, here. And what's interesting about them is that these are all the things with cache tags. So every single yellow outlined thing has cache tags. And the things with green inset box shadows are render cached. So we can see here that on this simple page, we have the shortcuts tray in the toolbar with cache tags for the shortcuts. We have a primary or secondary menu here and a primary menu here with cache tags for the menus. Cache tag for this block because it's placed. Here we have the most interesting case, which is a referencing entity, and it has a user, a tag, but it's also referencing another entity, and that other entity, as you can see, is also render cached. It has its own cache tags, and because of bubbling, that means that even if I do something like, for example, changing this taxonomy term, bar, into something else, because of cache tag bubbling, that means that the referencing entity, which itself is render cached, and therefore includes already this referenced entity, it's automatically going to be invalidated because of that information being bubbled correctly, and then it knowing by which things it should be invalidated, because it depends on those things, even if indirectly, just as in this case. So hopefully that makes render caching a bit more clear. So with that, that's all I had. I hope you liked it, and if you have any questions, just shoot. Thanks.
How do you determine if something is Ajax or something like the controller that builds the render error has no idea about that, right?
So the question is, how do you know if something is Ajax? I didn't quite get.
You said there's different request types, like Ajax and normal page and whatever. And at some point, you need to decide it based on input coming from the browser or something. And does the controller have any say in that? Or is it decided based on the request?
So the person over there is asking how is it determined that something should be rendered as an Ajax response? Can the controller override that? And how does SYMFONY/Drupal 8 actually determine which format to be using? So the answer is the browser sends, or the user agent in general sends an accept header where it lists the different MIME types that it accepts, different formats. So if it accepts HTML, it will send text/HTML. If it also accepts XML, it will also send text/XML or application/XML, and so on. And depending on the order, the first thing is preferred by the user agent. The second thing is a second choice. And basically, Drupal will see, for this route, can I return the user's preferred format? So if text HTML is the first, then it will try to render as HTML. If Ajax is the first, it will try to render as Ajax. But to your second question, which is, can a controller still override that choice, essentially? Well, as I said before, if you return a response object, any other logic is skipped. So if your controller determines to, hey, I want to send a foobar format response, you can do that just fine. So controller does have the final say if you want to, But of course, you should be careful to not break the browser on the client side as well. Did that answer your question?
Yeah, so but this also means that so if Drupal is making in the background an AJAX request, and then I think, oh, I copy this URL and just see what happens if I just paste it in the browser address bar, then I won't get the same response as the background request. I might not get.
So the question is, if I copy paste a URL, is it guaranteed to be returning the exact same response if that accept header is missing? That is the question?
Yeah, probably not.
Probably not, no. In Drupal 7, I think already not the case. Most of the time it would be doing exactly what you expect, but there is actually a discussion going on right now in Drupal 8, because Drupal 8 does ship with REST support, so it can render various entities in various REST formats, so by default JSON, JSON-HAL, and so on. And the question is exactly that: does it make sense to negotiate a format based on the accept header, or do we actually want to just use a URL, which is what you're asking about? And currently, it seems the discussion is trending towards just using a URL. So then what you are asking for would be working. The reason being that many reverse proxies, such as Akamai, the CDN, does not support the accept header. So in order to get maximum compatibility, we are probably going to end up doing what you're asking. Any other questions?
You figures out to know about some logic around it, display volumes, and so on.
Can you repeat it a bit louder, please?
Yeah, do the themes have to know about the logic behind this SYMFONY events and display volumes and something like that?
So the question is, do themers have to know about SYMFONY events and page display variants? Right, that's the question? No, everything remains the same as today. I don't think themers have to be aware of panels being used, but probably you have different templates when panels is being used. All of that remains the same essentially. It's just the underlying things that you have more flexibility and less hacks in order to achieve the same things that you can do today in those areas. But for themers, nothing changes in that regard, except the change from tpl.php to Twig files. All right, thank you. That's it.